Hello, good morning student. Yesterday what did we discuss? Yesterday we discussed this one, trans isomer 1 to E or AA form, or that is a type number second 1 to type, and we have considered here the trans 1,2 dimethyl cyclohexane. So far we have learned optical isomer, then second point we have learned conformational isomers. The last point remaining in this point is a relative stability. Relative stability we are going to find out here. Fourth point is a relative stability. Relative stability, right? Now to measure the relative stability, we must draw the structure of the organic compound. Again, let us see the structure, how to draw it. Let's see here, this one. EE form means what? One of the methyl group at equatorial position, another methyl group also at equatorial position, and this structure we are calling it as a 5 number, right? Now after the flipping, what do you get? Flipping is a process where the one chair conformation converted into as another conformation. During that process, the axial bond becomes as a equatorial, and equatorial bond becomes as a axial. So 1, 2, 3, 4, 5 and 6. As usual, the clockwise manner we are numbering here. After that, we are going to get the structure, this one, right? And this is the carbon number 1, 2, 3, 4, 5 and 6, right? Now look at a carbon number 1. Now this becomes as a carbon number 1 which has one methyl group at equatorial position. After the flipping, what is going to happen? That going to become as a axial one, and at 2 position this equatorial going to become, here is a axial one, CH3, right? Now put the mirror here, and as we know that mirror, what do you see in the mirror? You can see the mirror images of this structure, right? Now this is a equatorial position CH3, another one CH3. After the flipping, what do you get? After the flipping, the carbon number 1, 2, 3, 4, 5 and 6 as usual. Now after that, what do you get here? This one is going to get here. This is another structure. This is carbon number 1, 2, 3, 4, 5 and 6. This equatorial becomes as an axial one at 2 position. This equatorial again becomes as an axial one. Now this, we already learned this one. Now I am trying to explain the relative stability of those conformers. Now this is a structure number 6, structure number 7, and this is a structure number 8. In a previous lecture, we have seen the relationship between 5 and 6, or 5 and 7, or 6 and 8, or 7 and 8, all these things, right? Only remaining part is how to calculate the relative stability. For relative stability, to determine the relative stability, we must find out the 1,3 diaxial interaction, 1,3 diaxial CH3H interaction, or butane-Gauch interaction. These are 2 things you must remember here. One, while calculating as a relative stability, as we know that if the internal energy increases, those organic compound has energy, they are less stable one. That one general guideline you should remember while discussing about the stability of any organic compound. Now here we are talking about the cyclic substituted disubstituted cyclohexane here. Here trans 1,2 dimethyl cyclohexane. These are the different structures are there. Now what do you remember? Here 1,3 diaxial CH3 CH interaction. If only 1,3 diaxial CH3H interactions are present, how much energy it associated? It associates is 0.9 kilocalorie per mole of van der Waals force of van der Waals strain, you can call it as a strain, right? Van der Waals strain means that. And second point, you must remember the butane-Gauch interaction, right? Butane, GUACHE, butane-Gauch interaction, butane-Gauch interaction, and also it shows 0.9, or it is associated with 0.9 kilocalorie per mole of van der Waals strain, right? Van der Waals strain. This much amount of energy is associated with this. These two things we must remember while measuring the internal energy of this different structure. Now look at the structure number 4. What do you see here? This is the equatorial position, and as I told you that the equatorial position do not shows 1,3 diaxial interaction. Axial means if it is present at a equatorial position, how does it show the diaxial interaction? Because it is equatorial, and therefore EE means there is a no 1,3 diaxial present here, right? No 1,3 diaxial interaction present over there. But find out, is this molecule, these and these are the identical, 5 and 7, they are the enantiomer, and therefore their reactivity, everything is the same. Physical property as well as chemical property, everything is the same, because they are enantiomers of each other. Enantiomer means what? Non-superimposable mirror images of each other. Now there is a no 1,3 diaxial butane interaction, but butane-Gauch interaction, is it shows or exhibit butane-Gauch interaction? Yes, there is a one butane-Gauch interaction is present over there. Look at here, and yesterday we have seen how to find out the N-butane. If you draw the Newman projection formula there, you can easily find out the N-butane-Gauch interaction. So here simply remember here this group present at 60 degree, here also at the 60 degree, means they are butane-Gauch interactions are there. And let us see here, suppose we look here. After looking here, what do you see here? Look here. And Newman projection formula, there are the certain rules are there. According to that, one carbon atom we can represent by circle point and draw the circle around, means that is a rear carbon atom, means back carbon atom, and circle point indicate as a front carbon atom, and remaining groups are attached up to some center, some of the up to only as a periphery. These are the some of the rules that you already learned in your previous class, means in a SYBSc. Today here we are going to I am here also is not, but to understand what do you mean by the butane-Gauch interaction, how we are getting. Let us see here one circle, and there is a one circle is there, this point and one circle. I am trying to consider here, this is a carbon number, this look means this center carbon number 2, right? And this look means this is a circle point, you can call it as a carbon number 2. Now this circle, circle is a back carbon atom, is rear carbon atom, and this front carbon atom, this 2 and 4 joined with this one. There is a this hydrogen atom. Here one hydrogen goes below the plane, one hydrogen comes above the plane. Now at carbon number 2, one methyl group which is present here, you can draw one methyl group here, and another one is a hydrogen atom, we can show the hydrogen atom like this. Now here, right, now look at here at carbon number 4, both are hydrogen, one which is present here, another must be present here. I have drawn these bond are up to the circle point. Now this is a circle, and this circle, now look at here, carbon number 1 here having one methyl group, you can write as a methyl group over here, right? And now one hydrogen atom, we can write one of the hydrogen atom, and this bond is connected to this 6 one. You can draw one of the hydrogen atom here. This is a 6 one, this is the third one, and this is another hydrogen atom you can draw here. Now what is remaining here? The one carbon atom is over. Now look at as a carbon number, this is a carbon number 5, right? Carbon number 5 has 2 hydrogen atom. These 2 hydrogen atom you have to attach up to the periphery of the circle, and you are going to get as this hydrogen. And this is a representation of the Newman projection formula. This is according to as a Newman projection formula. According to that, now look at here, this methyl group and this methyl group, they are creating or generating the bond angle between them is found to be as a 60 degree. And if 60 degree is there, that type of the conformation is known as a Gauss conformation. If Gauss conformation, look at here butane Gauss conformation has a 0.9 kilocalorie per mole. This much amount of the energy associated with this means it contains 0.9 kilocalorie per mole. Similarly, this compound and this compound, they are the same, therefore reactivity of both are the same now, right? 0.9 kilocalorie per mole, this is also as a 0.9 kilocalorie per mole. Got it? Now look at the structure number 6 and 8. They are similar structure, they are identical structure. Now do you remember, if axial position is there, then and then you have to find out how many axial 1,3 diaxial interactions are present, multiple by 0.9, you will get the total energy of that, right? Understood that one? Now look at here, see the model there, then and then how many, what do you think, how many 1,3 diaxial interaction present over here? Look at here, this is a methyl group which is present at axial position. Here look at go, suppose the right hand side, 1 2 3, there is a one hydrogen atom, right? This is hydrogen atom, again 1 2 3, there is a hydrogen atom, right? And they are 1,3 position, and therefore they are creating a lot of steric interactions are there, and this type of the interaction is known as a 1,3 diaxial interaction. How many are there? This methyl group interacting with this hydrogen atom 1, and with this, so total becomes as a 2. Now look at here, this methyl group also at axial position, and therefore find out here 1 2 3, at 3 position there is a hydrogen atom that is at 1,3 position. Now again look at here, 1 2 3, there is a one of the hydrogen atom which is also at a axial position, and therefore there are 2 above and 2 below. Total becomes as a 4-1,3 diaxial interaction, right? And 4-1,3 diaxial interaction, and so total energy, how much is the energy? So 0.9 into 4 is equal to 3.6 kilocalorie per mole of van der Waals force. This much amount of the energy this conformation has, this having as a 3.6 kilocalorie, this also having as a 3.6 kilocalorie per mole of van der Waals strength. This is the energy associated with this, right? Now look at the model here carefully. What do you see? This is a trans conformation of 1,2-dimethyl cyclohexane. Look at, this is a carbon number 1 carbon, or this or you can see here, this is this you can look at the model here. Now look at this methyl group, which is below the plane. Look at in the model clearly, the methyl group which is below the plane means axial position, and therefore it is a axial. And look at 1,3 position here, methyl group 1, 2, 3. This hydrogen atom and this methyl group, they are very close to each other. They creating a lot of steric interaction, and that type of the interaction is called as 1,3 diaxial interaction. Now similarly, if you go this side, 1, 2, 3, this hydrogen atom approaching or creating a lot of steric interaction or hindrance are there, and therefore the internal energy increases with 0.9. So this below methyl group shows a 2,1,3 diaxial interaction. Similarly, if you look at this above methyl group and count here 1, 2, 3, this hydrogen atom and this methyl group, they are present at 1,3 position, and therefore they are generating as a generating as a 1,3 diaxial CH3H interaction. 1 and 2, 1, 2, 3 and 4, total are 4 by looking as a model that is clear to you, and therefore 4 1,3 diaxial interactions are there, and 4 into 0.9 into 4 you will get as a 3.6 kilocalorie per mole of van der Waals strain. And therefore if you compare the stability between these conformation, which conformation is more stable here? This conformation is more stable because it has a less energy. I already told you that those organic molecule has higher in energy, their stability should be less, and here 3.6, here only as a 0.9, and therefore this one is a less stable, this one is a more stable. This is all about the stability of this, means this conformation after the flipping we are getting as a less stable conformation, and therefore we can easily separate this from each other. They are the resolvable enantiomer. Now let us look at as a comparison of relative stabilities between the relative stabilities of the comparison between relative stability order of the following conformation, right? Comparison of order of relative stability of the following conformation following conformations, right? Now so far in case of the 1,2 type, we know that there are the two geometrical isomer. One is a cis isomer, second one is a trans isomer, and we total structure we got as a 8. Out of that 8, 2 are equal, means 4 structures are there, and out of that 4 structure, again there we are getting as a 3 types of the energy associated with that molecule, and that are, first one, for example, in case of the, what do you see here? One is a, suppose let us see here, E conformation, which has this one, let us see here, CS3, another one is a CS3. I am talking about as only one. This is a trans, this one is a trans 1,2 dimethyl cyclohexane, or we can call it as a EE form, right? Trans 1 2 E form. And how much is why it is a trans? Because if you put hand here, methyl group is below the plane, and if you put hand here, methyl group is above the plane, and therefore it is a trans 1 2 E form. Now let us look at as another one, another conformation which we got here. This one, suppose we have one is here CS3, and another one is this one CS3, right? And CS3 axial position and equatorial. What is this? One methyl group is above the plane, another also has above the plane, and therefore we can call it as a cis 1 2. What kind of the form it is? It is a EE form or EEA form, right? Now let me draw the another structure here like this. What is this? One methyl group which is above the plane, another methyl group which is below the plane. This is a trans, right? This one is called as a trans 1 2, that is a AA form. Got it? Now these are the three structure I have drawn here. These are the three different structure. This is a trans 1 2. I am trying to compare the order of relative stability of this conformation. Out of the 8 structure, we total got as a here. I have drawn as a 3 because rest of the conformer are similar or the identical with their energies. Now how much amount of the energy associated with this E? Just now we have seen there is a one butane gauge interaction is there, and therefore energy is 0.9 kilocalorie per mole, right? 0.9 kilocalorie per mole, because both are present at the equatorial position. There is no 1,3 diaxial interaction, only butane gauge interaction is there, and therefore one butane gauge interaction it shows 0.9 kilocalorie per mole. This much amount of the energy associated with this. Now if you look at here what do you see? One group is present at axial position, another group is present at equatorial position. One axial, 1 2 3, at 3 position there is a hydrogen atom. 1 2 3 there is a hydrogen atom. What do you see here? You can clearly observe, you can clearly see here there are 2 1 3 diaxial interaction, and as well as this methyl group also gauge, and therefore one N-butane gauge interaction also present over there. So total energy, how much total energy? Here you calculate 2 are 1,3 diaxial interaction and 1 N-butane gauge interaction. If you add this, total energy is calculated here is found to be 2.7 kilocalorie per mole. This much amount of the energy associated by this molecule, right? 2 are 1,3 diaxial interaction, and here 60 degree means that by looking at the Newman projection formula we can clearly understood that what do you mean by the butane gauge interaction, and from that one butane gauge interaction is present as well as 2 1,3 diaxial interaction is present, and therefore total energy becomes as a 2.7 kilocalorie per mole. Now here in a trans 1 2 dimethyl cyclohexane or AA form, look at here methyl group which is present at axial position. Count here 1 2 3. Here is one of the hydrogen atom which is present at axial position. Again look at 1 2 3. At this position the hydrogen atom which is present at axial position, they shows the 1,3 diaxial interaction. 2 are above with this methyl group. If you look at below methyl group, that also shows as a 2 1,3 diaxial interaction. Again remember here 1 2 3. What do you see here? Hydrogen atom, that shows as a 1,3 diaxial interaction. If you go this side 1 2 3, there is a one hydrogen atom which is also present at 1,3 position, and therefore they are showing as a 2,1,3 diaxial interaction. Below 2 and above 2 total becomes as a 4, therefore 4 multiplied by 0.9, so equals get as a 3.6 kilocalorie per mole. This much amount of the energy associated with this, and therefore how do you show greater than or less than? This one is a more stable than this one, because this is the most stable conformation among all these things, because it has only 0.9 kilocalorie per mole, and this is a 2 point. As internal energy goes on increasing, stability of this conformation goes on decreasing. That is the one general guideline you should remember while talking about this. This is all about the 1,2 type. There we have seen it shows the geometrical isomer means cis isomer as well as trans isomer. Cis isomer means AE form, trans isomer means is a EE or AA form that we learn in detail. And now I think remaining 1,3 type we will see, or we will discuss in the next lecture. Let us stop today here. Have a nice day. Thank you.